All right. What's up, everybody? What's up, Jane? Thanks for coming. And it'll be good to see all of you. We have some interesting software challenges tonight. So this particular stream, I'm going to be working on Bitboi Classic. So this is the NES game that I'm building for 88-bit music. So this... where we sort of left off last time, we had a lot of fun with the ampersand, and the ampersand got us. That bitwise and was a lot of fun to debug, and it turned out it was low precedence, and it was lower precedence than its friend, and that's why our logic wasn't working. So we got through all that, and we managed to draw a nice big ampersand in the middle of the screen. So I want to pick up from there and basically figure out how we're going to go deal with movement and physics. So in this case, we're going to keep things really simple. We're on the NES. We don't have a ton of memory. I'm not looking for super accurate. We want like platformer physics. So think like basic Super Mario type jump. You can turn in the air. It's okay. But what we need to figure out tonight is when you jump, you need to land on a platform. You got to land on it. You got to not go through it. We got to get some up and down sort of motion. We have to interrupt if we jump and you hit the platform on the way. So that's kind of what we need to do tonight. So I have not worked on this in a long time. When I was working on the NES Netflix app, Alex actually implemented the collision detection. So this is going to be a little bit cold for me. I haven't tried it in NES, so I should probably mark that this is a bit of a learn stream. And sorry about the go live notification. I realized I had the old one up there, so that was my bad. But anyway, to kind of get in the mood, I had the chip up. So this is the EEPROM that I programmed with our cartridge the other day, and we have an ESP8266. That's just a lot of fun, and I plan on doing some other stuff with that. So we're going to get back to that, and let's get coding. So this is the I found a quick NES Dev forum article on some collision detection techniques. None of it really jumped out at me too much, so I think if we really get ourselves into trouble, we'll read through this a little bit more carefully. Shiru in particular who's mentioned right here, wrote the C library that I'm using. This is like a forked version of the one that Shiru originally wrote. But so any thread that Shiru's in, it's probably worth paying attention to. There's a few other heavyweights in here. You got infinite NES lives, and so anyway, like there's some community stuff going. I've seen this guy. This usually is a sign that some logic's going on in the thread. So anyway, that's my cursory, not too involved in the NES forums kind of take on this. When I see those names, I'm like, yeah, all right, this is probably going to go the right way. So anyway, this is sort of where we left off. I did a quick make to make sure that we got a version of our ROM, and we can make run it, and that should show up here. So there we go. There's Bitboi Classic. And this was our tracked screen. And we had made it so that if we jumped to the next screen, we knew that there's our ampersand in the middle to remind us of operator precedence that I quickly freehanded. Here's two of the Schlorps. These are our monsters. And our main character is down here. So we have just sort of like up and down motion right now. So this isn't physics, right? So this would be the non-physics version of what we need. So what we need to do is, like, if you press the jump key, it does that, it goes up, and then it realizes this is a platform and it stops. So we're gonna have to figure that out. And oh wow, Sunny's here. I haven't seen Sunny in a while. So this this is kind of like, obviously this is an impossible level, so we're not really gonna build on a level like this. So let's get ourselves a decent level to work with before we dive in really deep. And because this is going to be, for those of you who voted, thank you for voting on the times in the Discord. So it's locked in now. I'm going to be regular on the hours. So as I put in the schedule, it's going to be Tuesday nights. We're going to keep the learn at the same time, which is 7:30. Wednesdays, 7 was the winner, and Saturdays at 3. And these are all Eastern time. So that's what it is. We're going to start that next week. Yeah, Sonny, you were demoted. That's gets into the discussion we had a few weeks ago that you didn't really reply to. But anyway, we are going to worry about NES stuff. So well, Sonny, if you want to get into that, we can talk about that after the stream. But it suffice it to say, I'm not happy with how you were handling performance numbers and just pulling things out of thin air. All right, so let's go. Let's see. We had the source. We have our source material, and we need our graphics, right? So let's go into Pico. And let's take care of, this was our level design right here. Okay, so that of course is obscenely large on my screen, so we're gonna fix that and get ourselves ready for some pixel art viewing here. And that's not what we want. Yeah, that's what we want. Okay, so here's our level in PicoPixel. So this is actually where we drew it. And what I did was I exported this to the version that we rolled into the ROM, and we managed to link that in, and it loaded into memory. So yeah, let's go get rid of our ampersand first. So I think that's probably a good place to start. Let's get rid of all that. And let's get rid of, what we really wanted were some slopes. So I think where we put that was, we came up here, we're too shy. So this is probably a good place for a platform. So let's just do this and give ourselves a little variation. So we'll stick with single jump kind of board, and that will get us pretty close. So if we do that and take this stuff, we can actually kind of fill this. Oh, okay, it doesn't want to fill. Oh, nice, PicoPixel does have a fill. Whoa, okay, so let's get rid of that hole first. And we're gonna dump this in here. And yeah, we'll just get that over there. So we'll just go with a simple slope level for the moment, and we'll add in a couple other ramps that we can sort of jump off of. So let's get rid of this, that. Yeah, all right. Let's go. Oh, and you know what? That is not what we want. Okay, so what I'm going to do is I'm going to flatten these because these are kind of some fun stuff. So, oops, no, we want to keep that. And these we can kind of get rid of, I think. Oh, you're gonna, what? Jane, where is the cider? Why? I went and got the wine for tonight, so I figured like, okay, on the Wednesday night, which today will be Thursday night streams, we'll make sure that we have a drink. So yeah, find the cider. All right. Course PicoPixel does not want to. Okay, there we are. Okay, so let's yeah, let's merge all of these. So we're working on a single layer, and we'll just do a quick one of these. So this needs to be something that we can jump to. We'll have to define how we want that to work a little bit later. That might be too hard. Well, we'll worry about that in a minute. So we should, if we get this right, well, let's not make this too hard up front. Let's take this and give ourselves some kind of normal-ish platforms to jump onto. And then this would be a nice little test set because we could, actually, let's not torture ourselves. Let's layer our test. So we're going to do a jump onto this platform and then, a jump onto this platform, and this one will make a little bit more complicated because we want to make our lives hard. So this, actually, I need a little more headroom here. So this should be all right. And one of the things we're going to need is we're going to need to get some debug information. So that's going to be a little bit challenging. So I'm going to go and dump out this as a PNG. And that gives us, yeah, that should give us, okay, so we're back here, and I'm just going to shut this down real quick. And so PicoPixel is chilling out. We're going to leave that alone. And we're going to look at, I think I left a make command. So there was a, yeah, there's an XXD here. And I left myself some notes. So basically, to get this out, we need to make our PicoPixel file, and then we need to dump it to a PNG, and then we run our Python level exporter, and that should pretty much get us to the data format that we want. That'll put it into binary, and then I take the binary and I make it turn it into a C include, and that's what I'm going to pull in for my level data. So let's just go here to tools, and we'll run our level exporter, which is, oh, see, we did usage. Okay, we did. We left ourselves a little usage bug there. So I'm going to fix that before we go any further. And that was about this interpolation. So this will be sys argv 0. Okay, so I'm actually surprised that ran. I thought that, yeah, okay, cool. I thought that throws an error, but I guess it didn't. So we're going to do that, and we're going to run it with our level 1 PNG, and we're going to send that to the code, which is in the source directory, and we'll dump that into level1.bin. Okay, so if we take a look at level1.bin, then this looks kind of mountainous. Okay, so this is probably our level data. So we'll take that and we'll XXD it, level 1 bin, dump that into level 1 bin h. Okay, so if we look at level 1 bin h, that's the bin, that's not what we want, level 1 bin h, then that gives us this same data, but now it's actually packed in a format that we can easily include. So here we get a nice variable. It's going to take up some stack memory, so we do have to, or well, I should just say memory. I don't think it's on this. It's really stack, but everything's global at this point. But it'll be there, and so we can pull it in, and it gives us the size, and this is going to be constant. So let's go into our program and pull that in. And I'm just going to open that up so that we have some reference. And let's go look at our level 1. So I included up there. This was where we were the other day. This was the line that cost us all sorts of trouble because of that ampersand that I drew on the level last time. And this was basically the precedence issue. So you had to make sure that you did this before you did this comparison. And that was kind of where things were going awry. Here I just rewrote this to be a little fancy, but what I ended up with here last time was this thing was getting compared to this thing, and then the result was getting ANDed, which is not what I expected. So we forced it with some parentheses, and we fixed that problem. And by the way, Jane, did you manage to find a drink there? Because now I'm going to feel guilty every time I take a sip of this. I mean, not so guilty that I can't have a sip of it, but I feel like the night's Jane. That's okay. Don't feel guilty. Okay. Jane, I feel guilty. I feel bad. Okay, so to tide you over, you know what I'll do is, the best I can do, because I can't send you a drink, is I can get you a little bit of coding, wonderful coding music. All right, so we'll start off with, we'll slow. I'm going to turn that down a little bit. Let me know that volume is guilty guy. Yes, guilty guy. Well, because, I mean, how can you eat, drink, and be merry if there's no... Yeah. This is, by the way, this is one of the Panera songs. He does fantastic work. So he's actually busy cooking up 6 more songs that I'm going to have for coding music soon. So pretty excited about that. We just had a quick exchange. I heard an early demo and I was like, man, that's some tight coding music right there. So, okay. Right. So let's get back to business. So we have our, so this is where our level kind of comes in. And at this point, it should actually just pull it all in, because this is actually the line that reads that array. So here's our level 1 bin array that you can see up here. And it's just pulling it in, and it's saying if the thing has any value, then go ahead and put that tile. And so I'm using the up arrow right now, but we can change that to a different tile. CCVE, can we play end product this game? You absolutely can, CCVE. I will be sharing it with the Discord, but there's only going to be, that'll be on emulator. There's only going to be one physical copy of this game that I'm going to create for someone, and that's going to be 88-bit music, because he needs to be able to put this in an actual Nintendo and play it on hardware. But I think emulator, if you want to play on that you will be welcome to. Got to shoot a playlist out on Spotify. Yeah, totally do. Well, you know, I'm commissioning works as fast as I can. I mean, I tell them, I'm like, hey, you got a little time? You want to write some more songs? You know, we've had an interesting back and forth. I've done some like just a few guitar licks. I'll send him an idea. He'll sort of like revamp it, come up with like something a million times better. He'll send that back, and then, you know, we'll so there's like there's a fun collaboration going on there. But anyway, that's. Oh, and Cam, I don't know if you're here. Oh no, you're busy talking on. You know what? I forgot to tell my my Discord. By the way, forgot to mention. Went live. Wine is out for night session. Wine is on the table for night sessions. There you go, a little more clear. Would you say you riff on riffs? Yes, we actually, yeah, but this is actually music. We're actually riffing in the real sense of riffing. We're not just riff. That's a nice icon, Jane. Where did you get that? Sings? Who is Sings? I'm going to have to go check that out. All right. So, yeah, the ADD is hitting. Right. So, if we go and dump this thing out, we should get the wrong directory. So, if we dump this out, then we should get a version of the current level. Okay. So, that's pretty good. We got all of this. Here's our platform. So here's a few jumps that are a little tricky. This looks a little not pleasant, but it should be good in terms of like testing collision detect. So what we're going to do is I want to put these guys on actual platforms. So we're going to take both of these sprites and we're going to lower them. And we're going to take Bitboi here, and he's currently top left aligned. So we're going to take him and sort of move him up a little bit. So we want that more like so. It's part of global. Yeah. I mean, it's NES, everything's global. There's no room for protecting memory and all that stuff. I was waiting for Discord to show that you were. Oh, you know what? I don't think I have a Discord like activity detect kind of thing. That's something I'm going to need to deal with. Oh, you know what, Cam? You coming in here, I just realized I didn't reset the audio sync. So the audio sync might be off with the video again. Ugh, sorry about that. All right. Well, let's keep that going. Let's do a little. Let's do some big beats. Looks within half a second. Did you say that the audio was ahead of the video? Is there a simple setting I have for that? I don't have to mess around with it too much. Yes, okay, so audio is too fast. So we want to like decrease that. No, that's not where it is. I don't know why this exact same setup does not have a delay issue on the other machines. I wonder if that's like encoding time that's different between the two. Yeah, it's not there. Sounds right for me. It isn't anything like the other night. Okay, that's even scarier that it's not consistent. So I guess we'll see if it like sort of drifts over time, but I'm not seeing the setting here. Filter. Do you have to filter it? No, that would be if we wanted to change the vocal effects. Okay. So, not that. Not that. Yeah, that's a good question. That thing, that thing. Yeah, I'm not seeing the setting for it. Audio delay, OBS sync. If this is involved, then I'll just do it later. Yeah, I hit that. I hit advanced. Oh, I missed that field. Okay, cool. All right, so let's look there. Sync offset. Okay. So just the audio delay. So let's try like, let's say that cam detected 200 milliseconds. All right, I don't know if that takes effect instantly. Cam is right, slight desync. All right, so like, is this, how far off was that? Seems close, getting closer. All right, so let's try like 400. You'll clip in, wait, clip this then and look. All right, so that one should be even closer. All right, anyway, I don't want to mess with it too much. We'll take a crapshoot on the sync. So, all right, so we do have our game, and let's bring our characters up a little bit. So we don't need this, the level's coming out, right? So let's put them, oh yeah, they're set up here, aren't they? No, yeah, this one. Okay, this is where the enemies are. And I think our character, sprite is the running total on the sprite. Here's our enemies, yeah. Where did I actually load Bitboi? So he's not on, yeah, this is on the tail. Oh, actually, I think this is Bitboi right here. So sprite X, this is the movement. Yeah, that is totally Bitboi right there. Okay, so let's take this and move him up would be a little bit negative. So let's like throw that like 80. And go with we'll do a little build on our music so that we have something to go towards. And we'll close this out. All right, not quite enough. So this should be like, I know this is the really technical way to calculate a position. Okay, so I'd say I'm about 2 tiles off. Tiles are about 8 apiece. So let's drop it by 16. So what is that? 68. Yeah, that looks basically spot on right there. Okay, cool. Let's take the slurps down a little bit. They're here and here, so this will be, they look like they're about 1 off, so this should be like 80. Let's just try 80. Okay, so they're standing on the platform, and that's all cool. All right, so our challenge now is basically, we want to stop that, right? So you can't go into these. And we also want to make it so that when you, well, let's not worry about firing yet, but we want to make it so that when you jump, it kind of does one of these, and then it sort of comes back down until you hit one of these boxes. All right, so that's our challenge. We're okay if you touch it, right? So like most of the platforms, you can go through a platform sort of like jumping up, but that doesn't mean that you're going to land on it, right? You have to kind of like land, your bottom line needs to be above it. So in the case of Bitboi, and Bitboi should really be on a power of 2, not a power, it should be a multiple of 8. So that was sprite X, sprite Y. So this is Bitboi. I'm gonna mark that because I seem to keep forgetting it. Bitboi location. So this is at 168. So yep, we're good. Okay, that's perfect even multiple. Okay. So this is the part where we have to decide on what sort of algorithm we're going to use. So the way I've laid out the tiles in memory, as you saw earlier, load level is processing that. And it's basically saying if it's a bit field. So I'm storing 8 of these in a single byte. So that's 8 tiles across. And I think we have 32 tiles horizontally. So that should mean 4 bytes of memory per line. So the naive thing to do is just run every single line. Now that's kind of a waste computationally, but we can get into like splitting the space. Let's start with naive and see how far we can get. All right, so I'm gonna just keep that up there because that's kind of good reference stuff. And okay, so let's see. This is our enemy stuff. We'll worry about moving stuff later. So we should worry about collision when we're moving. And that's kind of this section over here is kind of movement. This part handles the like shot firing and whether or not we jump to the next level. So I'm not really worried about these, but all of these are involved in hit detection. because we should worry about collision anytime we move. And this needs to translate into something more like a jump, but we'll worry about that. Let's worry about one issue at a time. So let's start with left and right. And I think the thing we want to do is, so if we're looking at like 4 bytes per line, we could jump the offset, because let's just do like, let's worry about like the right side, because that'll be our first thing that we collide with. So for now, let's just signal whether or not we have collision. So I think the way we can do that is, nah, that doesn't really make sense. Okay, well, you know what? I want to record this. Yeah, let's just go back to here and say that do you plan on creating art for this? Cam, that's sort of an open question. I'm probably, my thought is that, I mean, so Trevor already built art for the game that I'm basing this on, and I'm gonna see how far I can get, just sort of low resing his art. You know, obviously it would be better if like somebody with more pixel talent did it, but let's go for like fast and quick and see if like we get a reasonable full result, and then we'll worry about like resing up the art and, you know, getting better people. I mean, my budget was sort of like spare time, right? So it's not like I really wanted to spend a lot on the artwork. But, game design from an engineer's perspective. Yeah, absolutely. Oh yeah, we're going like, all right, how hard is this to implement? No. How hard is that? No. All right, that's easy. Okay, fine. Might not be fun though. So I want to stay a little bit true to the original game, like in the sense that like you're firing musical notes and you're collecting bits, and that's how you advance. And we'll go for a couple levels. But I think the really fun thing is like getting this to sort of approximate what's really there, but on an actual Nintendo. So, okay. And by the way, I've already created a bunch of pixel art for this, sort of based on the existing stuff. So if you look at this, this is sort of like so this is the this is Bitboi. Now again, it's sort of insanely small by browser standards, so you're not really going to be able to see it too well here. But that's Bitboi, and this was the bullet, which you can't see because it's black and black. And this is actually the platform block. So this is the Lego, and that'll be, instead of the arrow, that's what we'll use there. And this is actually drawing out the level, and the title attract screen you've already seen. You can't, it's black on black again, but you've seen it in the game. So the Lego is actually the tile that we want, but we'll worry about that a little bit later. All right, so we're moving right, and we're gonna look at level 1 bin. And where do we want to look in level 1 bin? We want to check basically where Bitboi is. Now division's super expensive because there's no hardware divider on this thing, so dividing is really slow. But let's worry about optimization later. We'll start off premature optimization, root of all evil. So level 1 bin, basically at the location of Bitboi. So we're looking at, that would be something like sprite x plus 32, which is really 4 because it's bits, 4 times the y. No, that's not quite right. So actually I've got y is going to be some number like So y looks something like this. So we need to know, so to translate that into a tile is pretty much like, so if we have like a number like 168, then if we divide that by 8, because there's 8 bits, so this is 168 down. In terms of how many tiles down, that would be that thing divided by 8. So, all right, it's 21 tiles down. Now, we're packing 4, because it's 32 bits per row. So we're packing 4 bytes per row. So that's 21 times 4. So that's going to be the 84th byte is going to be that row, and which tile it is going to be the X part. And the X part might be something like 12 here. So 12, I'm dividing this by 8, shouldn't be even, which means that this is not in the first tile, it's in the second tile, because it's a little bit more. So we have, but if it was in, actually, something's not right with my math there. And this is probably where we're going to go wrong in terms of collision detection. So this will be something like, let's see. So if I take 12, oh, well, hold on. So first of all, I need to convert it to tiles. That's 1.5 tiles over. So which means that's basically in the second tile. And I'm getting 8 tiles in one single byte. So that means this is in the first byte. And the way I would calculate that is it's because there's 32 tiles in the row. I feel like I'm making this hard for myself by trying to do it mentally. But yeah, you've got 32 tiles across, you got 30 tiles down. So yeah, we've been growing here, Cam. It's good. I mean, that's, if we wait long enough, he'll create his own physics engine. Yes. Interesting arrangement of numbers. Yeah. That's true, actually. Yeah, that's actually kind of a funny thing. Well, here, cheers to that. Okay, let's worry about this one at a time. Okay, so let's assume for the moment that Bitboi is on the first line. So Bitboi is set to render on the top line. So it looks kind of like this. And if I build that, let's just simplify the math before I go doing egregious things. And that, oh, I was sort of in the middle of a line here. So we're gonna stop doing the middle of a line. And yeah, okay, so he's up at the top. Now, which tile is he left to right? And that's kind of, it depends which way he's going. So when he's going to the left, I need to use the left side. When he's going to the right, I need to use the right side. So unfortunately, the first row isn't terribly interesting because I don't have anything up here. So, well, all right, let's fix that. Let's not be lazy with our graphics pipeline. So I'm just going to throw a quick, let's just say that you have a little platform to stand on here. And this is the collision. So you're going to be stuck in this little cage for now. All right, this is a terrible level, not a level we're ever going to leave in the game. So let's just save that. Let's export it and call that level 1 PNG. Okay, so cut back, and we are going to be changing the level a lot. So let me just fix that because that's gonna get annoying real fast. So let's just say level 1 depends on level 1 bin, and level 1 bin is dependent on, I'm just going to reach out a path here to graphics level1.png. So whenever that changes, we should rerun the Python, which is really relative to there. It's going to be .. tools v0 bin python, and we're going to do that with the rest of this line, level exporter.py, and that'll be let's see, relative to source, won't it? So that'll be .. graphics, and that's level 1 PNG. We're going to drop that in level 1.bin in this directory. Okay, so theoretically, that'll rebuild. No, can't open file because, right, it's not in this path. So this would be, I don't know if this is going to work with Python pathing, but well, let's try for a little luck tonight. Hey, we got lucky. Okay, so now we have a nice little make command. And so now Bitboi is up here, and we want Bitboi to get kind of stuck. And we'll worry about edge of screen collision a little bit later. So what we want is when it hits here, we want to signify that we hit something. And the way we're going to do that is right now we're going to start with this. Actually, you know what? Let's start. It's a few rows down, isn't it? Damn it. Is it okay if I wrap this around? Is that? Yeah, it seems fine, right? Okay. So I'm going to move Bitboi up so that he's definitely on the first row, which means that he needs a negative position, which is a little bit crazy, actually. But how far would that be? It would be, I don't think, yeah, you know what, if I do, I can let the compiler figure this out. So it would be up 16, right? Yeah, let's let the compiler figure it out. Hey, look at that, compiler's smart. Okay, so compiler realizes that it's an unsigned thing and it figures out. Now, we have the simple case here. So we're not worrying about the y dimension, we're just worrying about x. And let's say that when, and this is kind of what we were worrying about, but it's level 1 bin, and let's just forget about y for the moment. So what we can do is we can just take sprite x and divide it by 8, turns it into a tile, but we need to round that up. So that's going to be really slow on the NES, but the divide by 8 can be really fast because we can just shift, right? But the problem is we're going to lose the bit that matters. Let's see. Okay, so it's going to be like that, and that would be his tile location. And we know that there's 8 tiles per byte that are showing up. So if I take 8 tiles per byte, then I need to get which tile do I want? I mean, it should be like that divided by, it can be that divided by 8 again, right? All right, you know what? Let me draw this because it's just screw me up. Let's take a look at the whiteboard. So what we've got here is a failure to communicate. All right, so this is like, let's just cut over here to the whiteboard, and we have like our little jail up here, and this character is sort of chilling out here, and what we want to detect is, let's worry about this block. So at the moment we've sort of transposed this to sort of the simpler problem, which is, you know, we're not going to worry about the y dimension, but we're going to say that this foot block, and this is off the screen, so we don't worry about that. So what we're interested in is when this foot hits this tile. Okay, so the way that I'm kind of currently doing that is this top left corner here is sprite X, and actually, you know what? Let me make that clearer. This top left corner is sprite X, sprite Y. And we're ignoring Y for the moment, so we're just looking at X. And X of this thing, and what we really want when we're going right is we want sprite X, and this is in pixels. And we want to move that over to tiles. So to get there, we just take this thing and we divide by 8, and that ends up being tile X. And we add 1 to it because that's this tile, but we want this tile. So we add 1, which is that. And then what we do is we look up on our level, which has the information on where these tiles are. So that, and I'll just change to this for that. So if we look at that green here, then this is like 1, 2, 3, 4, 5, 6, 8, 9, 10. Okay, so this is showing that it's in 11. And the way that'll be represented in memory is these are all bits. So these are 0, 0, 0, 0, 0, 0, 0, 0, and this is like 0, 0, 1, 0. And this is our first byte, and this is going to be our second byte. And what I need to worry about is if I have 32 of these, which gives me enough for a full line, so to go from tile to bit, I need to get the second byte, which is well, actually, I need to check all of these bits that are in this row because I don't know if there's a collision or not, right? I can't jump straight to the. Actually, no, I can. I can jump straight to the tile that I'm intersecting because I know where this is, right? I know where this point is. So what I can do is, and again, that's going to be this side. So we're going to need to add 7 to that. But we don't want it to roll over into the next one. And this is kind of the tile that I'm this is the bit that I'm actually checking, and it's going to correspond to this remainder. So if I take this thing, which is tile X plus 1, and oh man, math and wine and days, and I go and I divide this by another 8. So this is to figure out that this is. So to figure out that this is where the second byte starts, what I need to do is say that this X, which is really plus 1 because we're going to worry about that, this tile is in the pack that corresponds to tile. Yeah, okay, so it is, because this is actually tiles divided by 8 again, because this is, we want this to be like 0 for this set, 1 for this set, and so on. So that means that at the 8th tile, I want this to kind of roll to, I want the whole number value of that. So that is, the whole part of that is which byte in the level. So that's level 1, bin, and that corresponds to the block, I guess we could call that. So the block that I want to look up is this thing again, divided by 8. And then that'll be plus the 1 and plus the little 7 part there. So we'll worry about getting a better collision in a moment. So once I got the right block, then what I need to do is we're just going to iterate through the remainder, which is kind of like when I divide this. So I'm going to need the modulus of this as well to figure out how far into the tile. Actually, no, I don't really care about how far into the tile this person is, because I'm only going to test it at the border. So yeah, that gets, you can see why I was having issues with this mentally. But so this thing is, yeah, that gives me the right block. And then to pull this one, I need to know how many of these over it is. So in this case, it's 3 bits. This is only going to get as precise as the tile for the collision, which is okay, because that's actually all I have for the map data. So this thing divided by 8 gives me the block. And the bit that I want is the remainder of this divide by 8 to tile space. So it's actually this thing. It's tiles mod 8. And that, well, plus, you know, the little bit, the fraction, just in case it rolls over. But we're going to worry about that a little bit later. So we'll do tiles mod 8 in order to get which bit. And then what we need to do is we need to shift off that bit to check. I mean, this is a single instruction, but we can just shift this value. Actually, we could bit mask it. Then it's going to be kind of messy, isn't it? So this basically tells us which tile we need to test. And we could use the same trick that we used with level, with our bit mask and. So we could take this thing and basically use it as our and for the 80 shifted over. So that was kind of that's taking a bit here and it's shifting it by however many bits this remainder is. And I have a feeling that might be the right direction on the right, and it probably is the wrong direction on the left. So we're going to worry about that first, coming in on the right. Erotzenplatz, how are you doing? Good to see you. I'm getting myself messed up with some math here. So it's so hard on the NES just because it's like hard to kind of see what it's calculating, because there's not like, you don't get a printf, right? So you have to build a printf if you want it. Yeah, I'm sorry, it is confusing, Cam. I'm gonna try to unroll that. So our first step is basically to figure out like which tile we're in. So right now we have sprite X. So I'll unroll this into individual operations and we'll optimize it later. So if I take this thing and divide it by 8, I'm going to get a number that's like, you know, a remainder. So if Bitboi, because basically Bitboi is sitting in pixel coordinates, but I need to know for the collision detect, I need to compare to the tile because I'm doing whole tile collision. So if he's standing on like X16, for example, like, so he's 16 over, then I divide that by 8 and I discover that he's standing on tile 2, right? So he's 2 over. And that's the tile I need to go look at which bit So for the level map. So there's two separate operations that I kind of have to do here. The first is I have to calculate like which tile. So let's just burn a variable for the moment and say unsigned char which X tile. And we're just going to start that off at 0. And let's say that which X tile is sprite X divided by 8. And for the moment, we're just letting the move go. And we're moving by units of 2, which is going to further complicate things, but we'll worry about that in a little bit. And hey, what's up, Paul Blart Maldcop? Messed up math is always beautiful. Thank you, Errol's and Plots. Of course, I don't have a very well-formed math problem, which is part of why this is going to be a little extra hard. But we're going to well-form it. That's what we're going to do. So we're going to take which tile the player's in. And what we really should do is just look at that variable. So why don't we see if we can see that in the debugging? Because that's, if I have which tile is in, so like in this case, I've got like this, the right side of Bitboi here. So like here, I'll just bring Bitboi into frame. But if I want this X, which corresponds to the outer edge of the right side, because right now I'm dealing with a move to the right. So I need the X value of this, but this is in pixel coordinates. So I don't want it in pixel coordinates. I want it in tile coordinates. So I want like when Bitboi is here, and I kind of overshot there a little bit, but when Bitboi is here, you can see clearly that he's in sort of tile 1, right? This is, well, tile 0, right? This will be tile 0. And when he starts creeping over, he's now in tile 1 on the right side. And when he moves over, that's tile 2 and that's tile 3. And the way I get that is I basically just take this pixel coordinate and I divide it by 8. And that should be, the whole value of that should be which tile Bitboi's in. Okay, so we start with that. That's which tile, and we're going to run that. And the debugger, if we can see how to use it, so we come in here and we go and look, and I haven't used this debugger in a little bit, but now the trick we need here is we need to know which part of memory that variable got assigned to, because it's not going to be here by name. So this is our memory map sort of down here. And what we want is the unidentified block. Nice. So NES RAM is actually what we're interested in. This is the wrong debugger to be looking in, isn't it? Yeah, we want the memory tool actually. So I'm going to close that, and we're going to go into memory tool. And memory tool, of course, doesn't have an overlay. So I'm just going to quickly throw this thing. So let's just add a quick memory window capture for messen mem. Okay, and that's our video playback, and that's cool. So we want this, which is our memory. So this is the live memory of the NES right now. And let me make that a little bigger so it's maybe you have a chance of reading it. So this is kind of the live memory that's updating right now on the NES. And what we're looking for is something that's going to roll over when I start moving around, right? So I move a little bit, and so here, this is moving. This is probably my pad input here. So you can see this variable moving. But we want something that gets bigger. So this is kind of like 5, 4, no. Where did it put it in memory? Ooh, a lot of stuff happening there. So we have a couple counters. This doesn't look too promising here. And this is probably, well, you know, easy way to do this is let's just give ourselves a pill to look for. So let's go with, this has the value B8. Okay, so when we find memory location with B8 in it, that's probably our variable. So we'll do that. And no, you can't do B8. You got to actually say this is hexadecimal. All right, so put that in B8. Actually, that might be a little bit too small to find. So let's just switch which tile, and then we'll just make the next one which tile Y, and B8, and this will be EF. Actually, here, let's use beef. So BE and EF. Okay, so let's find the pill BEEF, and we're going to go in here, and we're going to look at our memory tool. And if we search, can we search? Yeah, BEEF. No match found. Oh, it looks like it came backwards. So this is memory location 07FD. That looks kind of big. All right, well, we'll run with it. 07FD. Okay, so let's just pop this out and we'll confirm that we actually got it. And the way we'll do that is we're going to change this to like C3. So if the BE stays constant and the C3 changes, then we got the right memory spot. So come in here and 07F, there's 3C. No, looks like that wasn't it. So let's try searching. Find. No. No, that's not it. Nope. Huh. All right. Well, let's look at the disassembly because that's not really telling us. This is kind of the guessing approach. So if we look at main.s, see where which this thing. Oh, it's actually going on the stack. Okay, that makes sense because I put it in the function. So it's actually in stack memory, right? Okay, so we're going to pull that up to global memory so that we can find it. I guess we could static it, right? Would probably be a little cleaner. All right, so if we do that and we make it, and we take a look again at the disassembly, and we find which. There's no which. Which? What? Okay, so it actually just looks like it dropped it on. Yeah, do level. Okay, so these are actually the 2 bytes right here. It is in the data segment. Oh, 29. Yeah, just let me actually pull it up to global. I don't feel like dealing with that. Oh, hey, what's up, Craig Mark 0? Just joined the stream. What are you working on? I'm currently having some fun remembering how messin memory debugging works. So this is an NES game for 88-bit music, who has a kind of joke video where he puts a game that he built in GameMaker Studio into an actual Nintendo. And I was like, yeah, let's actually make that cartridge. So that's what we're building. And so question your words. I don't know, Cam is mod. I can't cyberbully anymore. But yeah, that's all right, let's see about that. Let's go look at where this thing landed in memory while I was doing that. So which X tile, and it looks like it's landing over here. So it's not in read only, which is cool. It's after level 1 bin, so it's going to be a little bit further down. And yeah, okay, so we drop through all that and we get to here, and it's right before this name chunk for read-only data, which is not far above that. So it should be kind of close to the beginning. So let's do that. Yeah, that's awesome. A web developer. So none of this is making sense to me. Cool. Cool to chill and watch though. Nice one. Yep. Appreciate it. Thanks. Feel free to chill. I do web development on some streams, Craig Mark. This is like kind of, I mean, we're getting assembly and low level here. So this is probably as low level as I'm going to get. Ooh. Thanks, Cam, for clipping the Bitboi Classic there. That'll be a useful. We should make that a bot command for people. So I'm gonna copy that. Try to remember to do that later. Yawning manly ladies punch trees. That's kind of amazing for a name. Okay, so right. So we should look for BEC3, and it'll be near this 5001 stuff. Okay, so let's take a look at memory and this. So we should find BEC3. Here it is, and it's next to the 5001. This is it, actually. This is exactly it. So here it is. It's landed in 04C4. So that's actually our memory address, 04C4. There is a way to get the linker to tell you exactly where that's going to get mapped into memory, and I totally forget how to do it. If Zorkenheimer shows up, we'll ask him when he drops by, because he definitely knows how to do it. By the way, do you manually add stuff like that to the bot? Yeah, at the moment I have it. We got to build some commands for that, Cam. I just haven't had time to do that. We just got our mods, right? Okay, so NetIM Chatterino. That's what happens if you mention an interesting project to a FreeBSD committer. Interesting. Are you committing on FreeBSD, by the way, or Odds and Plots? I thought you were just kind of having fun, but I guess committing can also involve having fun. Oh, actually, my Firefox wants to reset itself, so I'm gonna have to look at that a little bit later. Yeah. No, I'm not committed. Okay. Yeah, I didn't know. Yeah, I was like, no, you're just kind of into trying to get it to work on ARM, and that's a hell of a challenge you built the other day. So, right. We know where to find this thing in memory, so let's go screw around with it. So if we take this and we start calculating it actually the way we want, so we're going to take which tile now and divide it by 8, we should see the result of that in that memory location. So, and I'll leave the C3 there so that we can at least find the C3 if we forget. All right, so we come in here and we look at memory again. And what was it? What did I say? 4C4. Okay, so 4C4 is right here. C4. BEC3. That's not good. Did I not compile that? Oh, it only calculates it when it pads the right. Okay, all right. So then we know we're looking at the right place. So which tile X is the first one? That corresponds to BE right now. Which tile Y corresponds to C3, which is this one. So if we look at this, and by the way, let me know on the stream if the memory viewer is visible or if like the font is too small, because I could always cover up a little more of this window here. Okay, so the reasoning behind running previous demo? Oh yeah, it's cool. I mean, it's fun to do a port like that. Besides, the other interesting thing about building the whole thing with the Pi is that if you got all like the firmware blobs, the VPU init, like all the bootloader stuff, like there's a lot kind of going on there. Definitely guarantees you've got an open platform by the time you've got FreeBSD on it. Just having fun. Also, it's really stable. Nice. So I'm running my ZNC on there. Maybe it looks good. Oh, okay, cool. So now if I move him to the right, yeah, okay, we see that and it moves. Now it doesn't calculate it when I come back to the left because I didn't add it to the left pad, but when I move him here, this is 0. Okay, so right now it's using the tile of the left side, right? So when I cross here, he crosses into tile 1, he just crosses into tile 2, he crosses into tile 3. Okay, so our first issue is we need to do this +1, right? So this isn't quite right. We want to take this sprite, and it's really all of that calculation +1. Okay, so that should give us the right number for the right side. Okay, and if we come, oh, I'm going to know the keys for this pretty soon. Okay, so if we come here and we look at memory view, oh, can we jump? Like a jump to, oh yeah, go to OF04C4. Yeah, all right. So we're gonna know all the hotkeys soon. So we're at BEC3. That's our initial value, and oh, I don't know what state I just put messing in. Damn it. Oh, it's in pause state. Okay, so how do we unpause you? No. I didn't add pause functionality, so this is actually an emulator pause. And I don't know. I don't care. Let's just restart it. It's not like it takes a while to get there. Okay. So, oh, it was escape. Interesting. Okay, so we pull up memory and we go to 4C4. Okay, so we got the right memory address and we start moving this, and now it's not quite right. So it's adding 1 after. So it's wrong on the first tile. Actually, that's kind of okay. I mean, you're never going to be moving right onto the first tile anyways. That's kind of an impossible move. So yeah, this trips over. 20 is going to be all the way on the right side of the screen. And so the problem there is really that I should kind of do it before. So it's really this thing plus 8 divided by 8 would be. Now they should be equivalent, but I'm guessing it rolls over in the right place if I do it this way. So let's just check that real quick. Let me tell you this, collision detection is like one of those things, like if you're wrong with your position numbers, you're going to be totally wrong with everything. So, all right, so we pull this up, go to this place, and we start moving, and oh, it looks like I definitely killed my math. There's no question. I definitely killed my math there. That's bad. Okay, so don't do that. That's the wrong thing to do. Let's just take this. And that's actually, you know what? That's precedence. That's precedence is going to get me. Precedence is going to send me to an early grave. That's what it is. That's what's going to happen. Okay, so we're here and we move. Yeah, it was precedence. You see that? Damn it. Okay, so now we think we're in tile 1. We've got tile 0 wrong, but I'm not super worried about tile 0 because we're never going to be right checking on tile 0. I'll make a note though, just in case Wrong on tile 0 for the right side. Okay, so we'll just make a note there. F, nice. F's in chat, thank you, thank you. All right, so let's, okay, so we got our right division, and we're worrying about what happens when we get to sort of this point. So 8 should be a hit. So by the time this thing's equal to 8, we want it to hit. And the way we're going to check that is, let me just make sure that that's the right thing. 0, 1, 2, 3, 4, 5, 6, 7, 8. No, it's not. It's not 8. Oh, okay, 10. Okay, that's hitting at 10. So it looks like there's some fishy with our math. All right, so first tile shows the wrong thing, which we know. Second tile starts showing. Now, see, he's into the fourth tile now, and it's showing 2. So that's bad. That means we're definitely off by 1. So let's add 1 because that's wrong. So we're gonna do that, and no, not that. Go to here. You can see why it's always a priority to add it in screen display. Okay, so 2, 3, 4. Okay, this is showing 9. We're getting 9, 8, 9. Okay, and that is actually on tile 10, which if I start from 0 is 9. So this is good now. This is showing that we're hitting the right number. Boy, I'm glad we pulled this apart and did it piece by piece, because there is no way I would have gotten this right in one shot. Okay. That math is sadness. Okay, whatever. We're not going to worry about that. So which X tile is now the right number? And it's counting from 0. Counts from 0. Okay. So that means that the bit I have to look at in level bin is which X tile. Now that's the byte. So we're going to call this the level byte, level bin byte that matters. I'm going to be super explicit about this. And we're going to say that I'm doing this totally piece by piece. Okay, so level bin byte that matters is going to be that thing sub this thing. Okay, so that should be in the next memory location, so we should start seeing it next to our C3. So this 8D should get pushed over 1, and we should be able to see it there. So let's take a look if that showed up. And I did something bad because I forgot that. So we're going to do that, and we're going to go look at memory. Okay, here's our C3. This is level bin byte that matters. Yeah. No. Okay. Oh, wait a minute. Hold on. This is the... Oh, no, that should stay 4.0. What? No. Okay, so that's clearly not right. So this seems to be right, but for some reason, when this is 5, I'm getting... Oh, this is because I didn't scale it, right? So it's that thing, because I only got which tile it's on, but I'm packing 8 bits in a single byte for the level because I'm doing a bitwise operation. So actually that does look kind of right. So that means that this thing is really which tile, what is it, divided by... So this is where my second divide by 8 is. Because if I get which tile I'm in, say I'm in like tile 8, then I divide that by 8, I get 1. So if I'm in tile 9, which is fine because tile 7 would still be in the first byte worth of level bits. And by the time I get by 8, I should get the second one, which is really 1. And then by the time I hit 16, which is too many, no, okay, so if I divide it by 8, that's right, because when I roll over the... No, that's too early, actually. Yeah, because right now it's colliding here, which is 0, 1, 2, 4, 6. Yeah, it's too early. Okay, so that's... Oh, wait, but I didn't apply this yet. I'm going to rerun it. Let's do that. Divide by 8. Okay. Okay, we're going to look. Here we are. Here's our B3, BEC3. Okay. So we start moving right. 0. Look at that. That's right. Right? We stay on the 4-0 because we're in that block of 8. There's all zeros over here, and there's all zeros over here. Okay, so actually that's totally right. That because there could be an off by 1 in there. We're gonna have to check, but this 2, right? 4, 5. When this hits 8, this should roll over, and it does. And that rolls over, and it stays there for that group of 8 until this rolls to the next 8. And it rolls over again. Okay, so this is actually the correct byte. Cool. Now all we have to do is get the correct bit. So, nice. So you mentioned earlier that division is slow on the NES. Is multiplication faster? And if so, multiplying by reciprocal faster than division? No, there's no hardware multiply in 6502. I'm relatively sure. I'd have to check the data sheet, but I'm pretty sure there's no hardware multiplier divide. The ALU in a 6502, well, this is actually kind of it, isn't it? So you're like, I don't want the full implementation of it, but like I just kind of want which instructions there are. So let's see, there's like a add. Yeah. Okay, so like if you look at like the assembly of my do level, then when I get the divide, so not here, but when I actually get to the divide, which is this thing, in this line, you'll notice there's no divide instruction. So like this is an add with carry, clear with carry, load to A. There's branch, there's an increment, there's a jump, there's a clear, there's an add. There's only adds. There's literally just add. So dividing or multiplying are both expensive. And probably the way it's optimizing it, I don't know how they did their divide implementation, but it's, well, actually, this is how they did their divide implementation, but I don't know how much it's optimizing this line. It might decide like, oh, this is really just, actually, no, it didn't do that. This is the equivalent of a shift. So they're doing this, and then it's basically looping. It's like long division, bitwise long division here. So the number of times it's going to run the advantage is that later on, when we do need to start doing this, these are all working on powers of 2. So these multiplies and divides are actually the equivalent of shifts. So I can just turn this into a shift problem. Shift is really fast on a 6502. So that's why I was saying, like, we'll worry about optimizing later. Like, for now, we really just have to worry about, like, yeah, it's a crap load of cycles. I mean, how does long division work for you when you have to do it, right? It's an algorithm. You have to, like, divide this one, it doesn't fit, go down, subtract, divide this one, do that, except they don't have the subtract, so they also have to implement subtract with an add. So, but you can see here, this is where I'm doing the second divide. So you can see this is already like a lot of instructions versus like a shift, which would do it like super quick. But we optimize later. Okay. Hey, what's up, Nathaniel? How you doing? You should show Jesse the magic of optimizing compilers, like how to divide by 400 by only multiplying and shifting. That's totally an advanced course, Nathaniel. I feel like that is just... I hear you. Like, I want to get there, and she definitely has the mental capacity to do that. But I think that, like, I wanted to bring her through some more practical C before we look at this, right? Because like this type of disassembly, I feel like this is, I mean, we got to teach her assembly first before we can really like get there. But I mean, I will show her, I mean, because the thing about like the compiler when she's using GCC with ops, like it's automatically going to do a bunch of this stuff for you, unlike this CC65 compiler, which is fairly not optimizing. It's a fairly literal compiler. So it has some optimization, but I mean, it's not like you have to help it like with the ops. But anyway, I do like where your head's at. I think we should get to there. Okay, so we've got the right byte, and by the way, Nathaniel, I'm intentionally just unrolling like all of the lines for doing this collision. So I'm not trying to jump straight to the magic collision detect. So we take this level bin byte that matters, and what we need to do is we need to jump to the bit that matters in there. And we're going to use the same trick I used for the level, which is this basically. So we shift it over. This is like a bit by bit move. So what this is doing is I'm starting with the high bit set, and I'm moving it over by which bit I'm interested in this particular thing. And so in my case, that's going to be the remainder of that divide. So that's kind of, I'll leave that up here so we can see what we're building towards. So this is the level byte that matters, but to get the bit that matters in it, we need to count tiles. So this which X tile, if we had the remainder of it, if we had the remainder, then we would know which offset it is, but we're actually going to have to do this calculation again. So I'll just keep this. We're still going to go with simple version. So this is BE beef. We'll start it off. There's our pill. And this is which X tile bit. Okay. So the tile bit should correspond to which X tile bit. And we don't want to divide that time. We want to do one of these. And this, I think we don't have to nudge this by one, but we're gonna check that momentarily. And that should be which bit we want from here, and then we can worry about shifting it off. Okay, so let's get that. So that'll be the same thing, adding 8 to move it over. We're modding it by 8 to see how far into that current tile it is. Okay. Oh, that's actually totally wrong, isn't it? We don't want how far into the tile. We want how far into that group of 8 it is. So that's interesting because we need to, let's, yeah, okay, so sprite X, so actually what I want is like this thing, which corresponds to which tile I'm in. I want that thing, how far into that group of tiles it is. So actually what I want is this X tile, and I want it divided by 8, which is the same as this, I know. So that puts it into right, because the X tile, say like it's in tile 12, then what we want to do is we want to know that that's 5 into the byte, which is actually, yeah, it's a mod. Okay, it's a straight mod. Yeah, I'm just driving myself crazy. Okay, so that's how far in it is. If I take the tile and I mod it by 8, it's the remainder from there, and then that should be which bit we care about. Okay, so let's see if that works. What did I forget? I forgot this. Okay, so let's go back to memory, and we're going to pull up this thing. Okay, so here's our beef, and what we're watching is this one. So this one we know is getting set correctly. This one, we're not setting Y yet, and this is the byte that's getting loaded, but we're worrying about which bit at this point. So we move here, and that rolls over. Okay, so here they're the same because in the first group of 8, that's fine, except in the second group of 8, right. Okay, so when we get over here, it rolls back to 0. And here we're like 4, 5, yeah, 7, roll. Okay, cool. And it should do that at the end because we know that's a 32. Okay, so this looks like pretty good for like which bit. So if we take this thing, that's the byte that matters. And I'm sorry, this is just hurting me. I'm definitely rusty on this stuff. So if we take like which X tile bit, and what do we want to do with it? We want to look in level bin byte that matters. And what we want to do is we want to AND it with the high bit set, and we're going to shift it over by however much it overflows. So that's reversed. So it's really 8 minus this. Okay, so I'm doing this backwards. I guess we could do this forwards in this direction, because what we could do is we could just set this to 1, and then how many bits do we want to shift it over? No, actually, we laid the tile memory out the other way because we're taking the top bit. Yeah, I think we have to, I think I'm reversing that because this is, all right, well, you know what? We have a debugger, so let's just see what it is. Okay. The idea being that we want the bit to hit the field that corresponds to that tile. So in our case, it's 40 because it's actually on the left side. So yeah, it seems like it's going to be this thing. If this is like 3, then I want to just shift it over to the right 3. So let's just start there before I go doing any crazy other stuff. This is, the whiteboard would be useful for this. Okay, so go back to memory and where we were looking. Fortunately, our compiler didn't change any of our memory addresses. And right now we're looking at, so this thing is telling us, what is it telling us? Oh, I didn't store this anywhere. Okay. We're going to burn another byte, which is inside. So this will be level bin bit that matters. Okay, so this is level bin bit is this thing. Okay, so we're going to go and restart that, do the thing, and yeah. Okay, so if we go here and we start moving along. So what we're watching is in this group. So this is the byte that matters, and this is the bit that matters. Interesting. Now that hit as soon as I touched it. Right. So even though I'm in the right group here, you'll notice that this is still 0. But as soon as I hit the tile that's the collision, this shows up as a 4. So this actually sets. And really all I want to do is test not equal to 0. Because I'm using an AND on this, right? Yeah, I'm ANDing it. Okay, so I get that. And I say, if level bin bit that matters is not 0, then don't do anything. I'm blocking you. And then what we can do is we can say this. All right, and we're gonna have to clean all that up because that is really non-optimal. Okay, so you're not allowed to move. And it looks like we're solidly off by 1. Okay. All right. I like where that's going. I know it's a horrible implementation, and I'm not worried about that yet. All right, so this is like this, and right. As soon as this sets, it doesn't allow the move, which is kind of cool, except it's also kind of off by 1. That's a beautiful conditional. This is horrible code, Errol's and plots. I'm very sorry about this. I just don't want to reverse any Boolean line. I'm having enough trouble, like, mental state. And besides, I want to reserve the right to drink, so. Okay. So our problem is really that we want to look at the next tile. We don't want to look at the tile because we want to allow this move, but we don't want to allow the next move. So what we really want to do is say, it's not the byte that matters, it's the bit that matters that's off. So it's really this thing plus 1. And I have a feeling I'm going to burn in hell for getting precedence wrong again. So we know what happened in the last stream. So, oh, yes. Okay, the bit that matters, I'm trying to look a bit ahead. Wait a minute, I did the wrong thing, didn't I? I want to add the 1 to this. It's really this thing plus 1 is the bit that I'm interested in. It might be minus 1, actually. because I feel like it's in the other direction. Okay, let's try that. And oh, you know what? I'm gonna kill myself again. No, okay, good. I did do that right. That is not what I want, right? So this is, how far am I shifting over? Which X tile bit? Okay, so what I want to do is I want to see the tile later, which means that I want to shift. So if I start off on the first bit, I want to see that. No, yeah, I want to see that later. Wait, so why didn't that work? Okay, so if I run this and I take a look here, yeah, no, that's definitely wrong. So if I come in here and go to this location again, okay, so here I haven't loaded it yet. Here I'm moving and then I load it. And I've pulled the bit. So I don't want to load it. So really what I should do is, yeah, okay, so I should be adjusting which tile X bit. Yeah, it's pulling it too early, right? So, and the reason it's pulling it too early is 4.0 is the right thing, but it shouldn't have loaded that bit yet. Okay, so that would be which X tile bit +1. Yeah, this is what I get for cowboying this. Yeah, okay, so 80 level bin byte that matters. We know we're looking at the right byte because it's the next group of 8. So we're definitely looking at the right byte. But what we're looking at is the wrong bit in that byte. So this bit corresponds to the first one in there, which means I didn't shift it enough before anding it. Because I really want, yeah, that's what I did. I added one. It can't be add 2. Yeah, because my tile bit, that's which one I'm in the tile. So yeah, like, so this is like which part I'm in, right? So this is like I'm in tile 2, I'm in tile 3, I'm in tile 4, 5, 6. But you see, as soon as I switch over, this is still fine. And then I try to push right. And is this because of, no, it can't be because of movement 2. I say I'm interested in bit 0. Oh no, I'm in bit 0, which means shift over by nothing. And that's probably my problem. No, that's okay, because that would be the high bit. That would be like 80. So actually it shouldn't be changed at all. Because if that thing, if which X tile bit is 0, then I don't want to shift it. Let's see, 0 would be like the first bit, so that should be like the high bit. Why don't we write out the mask too? Because I have a feeling there's something here I'm missing. So as long as we're burning memory, because there's a ton of memory available on the NES. Let's just go and throw using this bit mask, and let's do using this bit mask. And the bit mask is going to be 80 shifted by which X tile? Bit. Okay, and then this thing we're going to shift. We're going to AND it with all of that. So don't try to do too many things in one line when the debugging is confusing. Okay, so we do that, and let's just see what the value is. Okay, so memory here 4CF. Okay, cool. So this is actually the calculation we're interested in right now. So that means 80. We should be watching this kind of like, yeah, it should be like 8, 4, 2, I didn't see, 1, 0. 8, which is right. So we're ANDing 80 with 40, and we're getting 0. Huh? It should be 0, right? So we're saying if it's not equal to 0, don't allow the move. It is equal to 0, so allow the move. Whoa. Okay. That's fun. So we've loaded this byte. Let's double check what order these are in. Okay, so this is still C3, so we know that that's this one. And then level bin byte that matters is getting 40, which is fine. We've loaded the right byte. The bit that matters oh, that's after we've done it. So this is the bit mask is next. So we're using 80. 80 and 40 is 0. Which is fine. So we allow the move. Zero is not equal to 0. Okay, so that's... I think it's time to relax our crazy conditional. Sorry, arrows and plots. Let's say if it's equal to 0, we're going to allow the move. So if it's equal to 0, allow the move. There's no collision. Okay, so it's equal to 0, it should allow the move. I don't see. Yeah, it's... Nope. Okay. Yeah, confirm. Thank you for confirming that 0 is equal to 0. You drive yourself crazy when you start doing this debugging, right? So we're going to go to 4C8, 4, and we're going to see that, right, so here's 0. We've loaded 40, 0. Why is it not allowing the move? That's... This is crazy. Okay, arrows and plots confirm that 0 is definitely equal to 0. Okay, so 0 is equal to 0. 0 is equal to 0. Why is 0 not working for me here? Okay, So 80 and 40. We need to write up on that. I'm going to need to check your data, arrows and plots. I'm not, I mean, is that n equals 1? How many zeros did you test? Like, no, I got something is definitely wrong with this. Okay, so, yeah, the papers, nice. I got to check your sources. Okay, so, yeah, going crazy aside, okay, let's see that we got this all in the right order. So this is kind of X tile bit, Y tile. Okay, so X tile bit, Y tile. Byte that matters, bit that matters. That's the bit mask. So we're applying this bit mask to this byte that matters. 8 and 4 is 0. So why is it not allowing them to move? Level bin byte that matters. Level bin byte that matters is this. Actually, that's the wrong check. It's level bin byte that matters. That's just the byte. That's not the result of checking it. This is the bit that matters. I didn't do the right operation. Okay, so that's right, because this is like, it's not allowing it as soon as it loads it. It's 40, so it goes, yeah, you're not allowed to move there. It's not 0, because 40 is not 0. So what I need to do is I've peeled off this bit, right? I've got the bit mask. I'm ANDing it with the byte that matters. And then I'm getting the bit that matters, and I'm checking it against the byte. Oh, damn it, guy. Because if that is equal to 0, allow the move. Okay, so let's see if I'm totally nuts. I'm totally nuts. You see that? Okay. Now I deserve a drink. All right. Let's send us a link to the Wikipedia article. 0 is equal to 0. We've confirmed the world is not totally crazy. All right, fine. For some values of 0, this program works. Programming drives you to this. Okay. Totally works. Okay, I feel a little bit better about that now. Cool. So now we have hit detection. One way that we could, Y is actually kind of a different story, but in the case of right moves, Y is very easy to compute. I say that now, which is going to make this terribly difficult. Just watch. But what I'm thinking is that your Y offset is really, so once you can calculate the right tile for Y, it's just 32 times that, because we already check how far over in the line. We just need to know that we're on the right line. So to get the right line, and we're only worrying about the right side collision for now. What we had was, okay, so we're going to go to here and, okay, sort of don't want to touch it. It's like you get it to work, you're like, yeah, stop. Okay, so good. We burned way more memory than we need to figure that out, but whatever, we can always optimize it out later. Okay, so that's neat. So what we really need to do is add in, we need to know which Y we're on. And the way we get which Y we're on is we're going to work with sprite y now. And sprite y is, again, in bit. So if we do this thing divided by 8, it's not divided by 8. Oh, yeah, we're talking about y. Okay, so if we're at like 12, then that would be 2. Well, 1, right, because it's started at 0. So if it's like divide by 8, and this is going to be round down type operation. So divide by 8 would be 0, which is what we want to be on the first line. And if we're at like location 12, divide by 8, it's going to be 1 point something, so it ends up being 1. Okay, so that gives us which y tile. So that sounds right. We'll fix it in post. We can always optimize that later, and that's why Call of Duty's 400K. No, Paul Blart, I have earned the right to use that line because I'm a performance engineer. That was actually what I was doing at Netflix. I've done it at multiple jobs before that. My primary responsibility was to deal with other people that said that line. So I've paid all sorts of karmic bucks to be able to optimize later. So I'm going to optimize later. We're going to start adding the shifts and all that other crazy stuff in there. So, all right. So this is our which y tile, which currently was set always to C3. So that was kind of what we were using as our marker. So I'm going to add another marker just so that we know that we're like in the right place. So I'm just going to say unsigned char marker mem marker. And we're going to say that this thing is an array, which is like dead beef. Okay, so we're gonna use dead beef. Or what was the sun one? What's the Java one? Cafe babe. We'll use cafe dude. Yeah, you get E. Is that a? Do I have a number that's closer to U? What can I do for U? It's 7. Nothing's really close to U. Dude, that's cool. All right, food babe. Nice. Yeah, that's what it was, like Java. All right, so that should give us enough. I don't know if this is going to accept that, so we might have to unroll that. No, okay, cool, we're good. So we're just going to check that our memory marker is good. So we're going to go to here, and there's our beef. That's the wrong beef, isn't it? I don't have beef with you. Okay, it actually didn't put it where I thought it would. Yeah, mem marker, it's right before it. Oh, that is our marker. Okay. Cafe. Where's cafe? Am I just not seeing it? Did that not compile? No. Oh, all right. I go crazy? Is 0 still equal 0 or else in plots? Okay, we're gonna go here and we're gonna go here. Yeah, cafe is not showing up there. Oh, you know what? That's gonna endian me away. You can't do that. Okay, so you gotta like so let's give it one of those. Terminology is really yeah, I have a feeling that was just an endian. Yeah, that was it. I got endianed. I was endianed away right there. Okay, so cafe dude is right there. All right. and beef was going to get overwritten. So I've just shifted over stuff, and so this is kind of like my fun work area. So now we're starting to reset y, right? So what key did I map to? Oh yeah, it's X. Okay. Now it's only calculating on a right move. Okay, so this is off the screen. Okay, so for this, we want to use the bottom of the character, not the top. Which I should probably make a mark of. So I'm going to totally get rid of this. Use the right side for X, and we're going to say use the bottom for Y. So it's really going to be sprite Y plus however big Bitboi is. Bitboi is 3 big, right? So for 3, it should be like 0, 1, 2. So it'd be like 2 times 8, which, all right, so if we put it like so, okay, then that, all right, we're gonna jump to here, and we're gonna move things. No, it's rolling over too early. Okay, so I'm looking at this memory location, and this is not good. So I need to add a little more to it. So it's probably one more tile of 8. Okay, so let's go and do this. All right, so that's what we're looking at. No, that's definitely not right. Oh, I've got another order of operations, don't I? Dividing it by 8. I'm taking 24, dividing it by 8, and then adding it to the thing, which is totally wrong. Order of operations. Okay, so we're gonna go here and here and here. Okay, so we're watching this. We notice the number changed. Okay, and it seems to be kind of tile-ish. So that looks like 8. Still 8. This should be 7. Okay. So this is not right. So we're not good up here. So where is it getting right? It's kind of getting right. So there it thinks it's on tile, it's on row 3. And actually that is right. Oh, because we need to overflow it first. So if we take like sprite Y, are you putting an ESP8266 in the cart for some sort of, no, I'm not. The 8266 is just for, that's for the Power Glove project. So I just got both on my table because I'm working on both. That's for the 10 degrees of freedom sensor that I'm putting, this is what I'm putting in the Power Glove right now. So that's, maybe we should make this a Power Glove friendly game. But, yeah, the 8266 you don't, I mean, you need 5 volts. So like I need a level shifter. And plus you don't really have a lot of pins on the 8266. So like I mean, there's not a lot of there's not a lot of usable pins. So you'd be doing a lot of serial shifting. Like I would pick probably a part with more pins to work with. VR. That's where we are going, by the way, Cam. But you heard it here first. Okay, so I've got some sort of bug here. So when sprite y plus 24 divided by 8 seems to be right after this is big enough. So it's not overflowing fast enough. And actually that makes sense because the Nintendo doesn't, it's not 256 because across it's 256. Down it's not 256. It's 240, right? Because you only get 30. You only get 30 tiles. Ah, crap. So you can't even do it that way. Okay. So actually that's the edge case right there is it's not 240. So it's really if that's our problem. You know what? Let's just do 1 divide. All right. So let's do this. Yeah, no, it's discontinuous, right? Because when we're in between 240 and 256, we have to actually bump it to the top. So it's really, it's not, I can't use sprite X really. I mean, let's say corrected sprite X, sprite Y. And corrected is going to be, all right, you know what, before we get crafty, let's just do it the messy way. All right, so if sprite Y is greater than or equal to 240, then this is kind of our weird case. Otherwise, this should be right. And we want to end up with which Y tile is a nice continuous function. So which Y tile in this case is really going to be sprite Y. Let's just overflow it because addition's faster. So it's this thing plus 16. And then we want to do all of that other stuff. So it's 16 plus 24. We'll see if the compiler optimizes that. And then divide by 8. Okay, so let's test that because that's kind of screwy. Which Y time? Which Y time? It's not which Y time. It's which Y tile. Tile, you dude. Okay. So let's take a look in memory, and let's go here. Okay, so we're watching the Y this time. So this is our Y. I think I added 24 at the wrong point. So 3 is right? So we left that alone. But that's wrong, and that's wrong. In fact, it's too much. Because that's when the top of it hits. But I don't want the top of it. I want the bottom of it. Oh, may I quickly make you jealous of those sweet Red raspberries I got. Absolutely, Erolson Plus. You have a picture of these raspberries? I love raspberries. I love raspberries, the fruit. I love raspberry pies. I love raspberry pie. I love basically everything to do with raspberries. So, yeah, feel free to just drop a link. Okay, so okay, so 240 was kind of our problem area, and that should be, if I'm doing the math right, which let's check our math at this point. It's 30 tiles. Why did I do that? It's 30 tiles, 240. Yeah, it's definitely 240. Okay. So I'm going to make that clear by just unrolling this. So 230, or re-rolling it, I guess, because I unrolled it. It's 30 times 8, right? So that's 240. That's the bottom scan line. Now, when I'm at the bottom scan line, I want to add 16 to it, because 16 is equivalent to 2 rows. There's 2 missing rows in the V blank region, and those are 8 apiece, right? So that's my 16. That puts me back at the top. Now I'm adding 24 there to get the bottom of the tile. To get the bottom of Bitboi. And then what I'm doing is I'm dividing that by 8. Which that should have worked. I had to mow bush hog with a tractor. Some blackberry bushes one time. It was crazy. I now know how barbed wire can actually be. Oh crap, that sounds terrible, Cam. Okay. So yeah, 24. So this thing, what am I doing here? This is, I mean, so the 240, you know what, let's stop being crafty. I'm trying to overflow it, but maybe it's 16 bitting in the middle of the operation. So let's just say if it's above there, then subtract it. So worry about optimizing later. So if you're above 240, subtract 240, and then we're going to continue doing math. And when it's 0, it should be plus 24. That should be the top line on the screen, because that's the bottom of Bitboi. And that divided by 8 means that you should be in tile 3. And that's not actually the problem. The problem is the less than that. So actually in that case, yeah, that's actually what's wrong, isn't it? Because say it's like 240, I subtract 240, I get 0, I add 24. Actually, no, that'd be right? Yeah, so it's really before that. It's before 240, because the thing is 240 is actually 0. So because I'm using sprite X, which is the top. But actually it's rolled over when Bitboi is here, right? When he's here, actually his bottom is, the bottom tile is already on the top row. And that's actually the problem. So this might be 240 on the last line, but I'm not comparing the last line, I'm comparing the top line. And that's actually where I'm screwing this up. So it's this thing. Yeah, 240 is actually 0 in this case. Yeah, I've gone crazy. All right, I'm gonna have to pull this up. And I hope this is safe, arrows and plots. Oh my God, it's not safe at all. It's beautiful. Look at those beautiful raspberries. That is torture. Damn, and look at that nice, is that teacup you got over here? Oh, that guy just 240 and 0 is all the same to him. He doesn't know what the hell he's doing with it. All right, so those look great, and I like that this is T here. That's for tree, isn't it? Espresso cup, nice. Man, I can't drink espresso at night. I'd be wired. Also a nice keyboard. Yeah, nice clock going on here. That's pretty cool. Where's the FreeBSD Pi? I want to see. You got Pi and Pi, right? And that math, that's just bad math. That's just terrible math there. I can see the bad math on the screen. Okay. So yeah, what I was just getting to was that I don't really want when it's at that point. I want kind of before that point. So this is the case sort of on the last row. But really I got to hit that before. And specifically I got to do it when it's 16 before, 2 rows before. And I feel like that's going to bleed the right spot. And what I should do with that is subtract it back out. Okay. Start with the semi-wild guess. Okay. Three, 4. So these are actually right. 3, 4. These are right. And then yeah, because this is the memory I'm looking at, right? 4, 3, we're all right. And then our other side of the if, and this is kind of where we're wrong. 5, 4. Three. Okay, so actually that's what's wrong about it, is I don't need this. Because I implicitly have it from the 16 on the other side. So let's go here and go to there. And again, we're watching this spot. Right, so 3, 4, we're okay. Not quite. Sorta. We're just off by 1, really. 0. Which that's kind of right. It's just not drawing. That's dead wrong. Oh no, I'm going up. Okay. That's right. Okay, so then I touch. So when I cross the bottom, this is where I'm not quite hitting it early enough. So that's probably my off by 1. It's not 16, it's really 24. Off by 1 here is 8. So all kinds of terrible math. That's, okay. Okay, so okay, so this is the right spot. That's wrong. That's kind of right, relatively. I'm not really worried about this case where Bitboi goes through the ground. This is the problem here, is it shouldn't be 3 at this point. It should be like, this should be 0. Well, for the bottom, right? So we want that to be 0. So we're off by 3. So, and then this one, yeah, we're off by 3. No. Oh yeah, and this is where it flips to the other side of the condition, which is actually correct. So it's really just this point that we care about, and that is off. That's off by 1. Because this is really row. This is correct row 3. This should be row 2. This is off by 2. This is off by 2. This is off by 2. Okay. I have a simple fix. Because it's getting late. And if we're off by 2, we're going to just be off by 2. I know, it's terrible. It's terrible. It's terrible. All right, so we're on 1, we're on 3, 2. Look at this. 1. Okay, so actually we're not right, because this should be like line 0, but it's line 1. Actually, it's continuous now, isn't it? 2, 1, and then this is wrong. Oh no, it's right. It's right. Yeah, it's continuous. This is totally continuous. Okay, so that's good enough. All right, let's see if we did more damage down here. All right, so this is like 1D. That's bad. Okay, so this is like 1D, 1C, FE, not good. Ship it. Okay. It's a little, this is definitely jank, right? So this is clearly wrong. Now what we're calculating is not actually the tile Y. What we're calculating is the bottom tile Y. This is the tile of the bottom of the sprite. And it's kind of jank. I mean, we should really clean this calculation up. This freaking... All right. What are we doing wrong here? So first of all, we've got two different meanings here, right? With which X tile we're calculating the X tile on the right side. Oh no, so actually I am right in not calculating the top. I'm calculating the bottom. Now the problem we have is sort of in this V blank area. So first of all, Bitboi can't be in the V blank area. so like we've already got a problem if we're calculating that value, right? So if because yeah, you can't run into V blank. That you're not allowed to go down into V blank. It's terrible. So actually I'm okay with it being sort of wrong. So let's make a note there. This is wrong in V blank. What did we observe? Like FE, FF. It goes from like 1D to FE. It's like 1C, 1D. Whoops. That's a lot of whoops. Let's not whoops that much. Let's whoops. And FE, FF. Okay. I'm not really worried about that case because that's an illegal case to begin with. So straight to prod, don't look back. YOLO. Okay, YOLO to prod. Let's get more torture here. That's nifty. Yeah, nice bowl. Nice keyboard. All right, so I'm gonna keep. Let's have some ALU graphics in the background. So, there's a guy on YouTube that manually jumped at certain points in Super Mario World on real hardware. He added 331 ways. I actually saw this. Yeah, I remember he used the coin counter as his debug display, and that's actually part of why I was thinking like I should add a coin type counter so that I can have a printf of like a memory address without having to look in the memory viewer. But it was a really nice like run. I remember originally they did it like tool assisted, and then they figured out how to do it manually, and then like he built a loader, and then he just loaded the whole thing. And this is the kind of thing where I'm letting that happen. But that was a fantastic video. I love that video. I just love that concept. Like, I guess not so much the video. All right, so we're back in. Let's not worry about that. So we're just gonna say like if it's we'll save ourselves. If it's greater than then we'll just pin it because this is kind of an illegal value. So we'll just like pin it to, I don't know. I don't know, 0? What? Yeah. Not really sure what makes sense in an illegal thing, but at least it gives me like a better spot to put a note about like something bad happening. So yeah, let's just go here. And we're doing this and we're doing that, and we're coming here, 2, 1. This is, by the way, where we're looking, and 0. FF. Wait, how did that slip by my loop? FE. 1D. Yeah, see, 1C. These are all continuous until you hit FE, and that's something bad. That's weird. You know, you try to add like something to do the right thing, and then that ends up killing you. So am I not actually hitting this? Or is it getting reset? No, it's not getting reset. Okay, so I think I'm just not, how could I not hit this? Is this like an illegal comparison? Let's stay in the same units just for fun. So if you're here, let's do an overwrite. Actually, you know what? Let's do this. Oh, you know what? I compared the wrong thing. Okay, so let's just say if this calculation is greater than or equal to this, then set it to 0. All right, fine. So that'll be our sort of like idiot check, because I am not getting that math right tonight. All right, so we close this and we make it, we run it, and we come here and we go and we look at memory, and that's 4C4. Okay, so we're here and we're kind of like looking around here, and this thing is what we're watching. So we come up here, 2, 1, no 0, which I don't like. Yeah, okay, 0, but we can't really see it. But actually, legitimately, that's the next row, so I'm actually fine with that. So this 0, 0, 0, because these are sort of illegal, and D. Yeah, so okay, so it goes to D, and then it cuts to 0. So this is sort of the start of the illegal values. So we're going to need to catch that later, but that's kind of fine, right? So we've now created a continuous function out of this terrible math. We've crossed back into the tile value is sane, which that I thought was going to be easy, and of course nothing's easy, but okay, so this is fine. We end up with a sane y tile value. So now that we know what the y tile value is, let's take this and we're going to go here, and now this time we're going to take which y tile and we're going to multiply it by so there's 4 bytes per row, right, which is the same thing as saying that there's 32 divided by 8 per row, and we're going to add to it this thing, and that means that so this is like 0 when I'm sort of off the screen, but kind of like on the first row. So this will turn into 0, which is fine. So this term ends up being, and I'm just going to be really careful about precedence because it keeps biting me. All right, so this term will turn into 0, and then when this thing hits like 1, this divided by this, by the way, this is like 4, so it'll multiply by 4. So it'll this is how we're going to do our multidimensional array. So this is going to jump us to the right row, and this is going to jump us to the right column in that row. Well, not just that. It's going to be that plus this other thing will get us to the right spot. But that's okay because they build on each other, and they're working off level byte that matters. So this should be enough to do collision anywhere in the level. So that is kind of crazy. Okay, so this we didn't break. We still can't go over because it's doing the collision below, and that's fine. Look at that! Look at that! Hey! Now it ignores the sprites, that's okay. But now this is stopping on the right when it hits a tile. See, I can go through it this way, but if I hit the tile, yeah, hitting a tile, allowed to stand on the platform, hitting a tile, hitting a tile, hitting a tile, allowed, because we're not checking the top. And this is sort of that oh yeah, I went into the tile. So if you go into the tile, you can't move, you're trapped. So don't go into tiles. But if we come here, then yeah, we're totally fine. See, we can't go right on it, but we can go left through it. Hey, all right, we have a working right collision detector. All right, so now we just have to do every other direction. Great, that is definitely where we're going to stop for tonight. So, that was more painful than I was hoping for. So, yeah, the NES. There's like a lot to do for like kind of pretty straightforward stuff. Now, obviously, there's better ways of doing this collision detection. I'm reusing my level loader as my collision detector. A lot of games use geometry. They use different tile situations, like if you're going sideways, if you're going, whatever. Like, already better than Fallout 76. Oh, burn, Paul Blart Mauled. Burn! Okay. That's cool. I kind of like where that is. So let's definitely call that is as far as we're going on pad right. Now look at all this code just to check on pad right. Now most of it is going to be generalizable when we figure out which side of the character we're testing. Like, so that's where a lot of these 24s and 16s are coming from, because I'm sort of like going for the bottom right, as opposed to, and I'm not testing the other. I mean, there'd probably be like a for loop in here. Like, do you want to allow the person to jump? Like, how much do you want to allow them to go through a tile? Kind of is the question. But generally speaking, this will stop the character from running into a thing. So they'll have to jump on it, which is sort of fine. But that's actually pretty cool. I know the code is terrible. So that's where like we can get rid of all these multipliers. Now I'm not worried about the constants, because the compiler will take the constants out, or should take the constants out. I mean, we could go take a look at what it's really doing. I don't know how much like constant folding and other bits of fun are happening in here, but like if we look at this like SPRY line, so yeah, the compiler did the right thing. So I wrote this for clarity, right? It was 30 tiles. Each one is 8-bit, is 8 pixels wide, and this is a height calculation, so 8 pixels high. And then I'm subtracting 24 for the size of the sprite. Now that all turns into, this D8. So it actually is already turning that, it's folding the constant, right? So it's taking this and it's going, well, that's really equivalent to doing hex D8. So that's not costing us anything in runtime, unlike the divides that are happening that are non-constant. So this one, for example, is actually like doing a divide, right? So this one would matter, but that we would want to try to turn into some sort of shift, which we've got all sorts of 8s and like power of 2 kinds of things here. So like we should be able to shift it. So that's yeah, that's pretty sweet. I'm pretty happy with that. That was a little harder and messier than I thought it would be, so I apologize for that stream. There was definitely debugging. This is kind of I didn't prep any of this, obviously. So this is like the real work. But yeah, that's pretty cool. I'm tempted just to, because that got brought up, to just do a quick little you know what, let's quit. Let's quit while we're here. I mean, I was thinking of like, it might be fun to add like a coin counter type thing. I think we should save a little fun. Yeah, I don't know. Do we want fun? I don't know how much we want fun. Yeah, call it a night, because I'm out of wine, so that's clearly not going to work. So yeah, let's call it a night there. Anyway, I want to thank all of you for dropping by. For those of you who voted in the Discord, thank you. The schedule is now up based on votes. So what are we doing? We're doing Tuesday, Wednesday, Saturday. So Tuesday evening with Jesse, learn. Wednesday, one of these kinds of sessions. We'll have wine. Saturday, no wine. It'll be like kind of a mid-afternoon session. And yeah, I'm going to be going pretty hard on Bitboi. I want to get this finished, and I want to get it burned into silicon. Like let's get this like chipified, and let's get this onto an actual cart. So that means I got to deal with these other cases. So that'll probably be some of the next stream. And then I want to get onto that power glove that I started showing you. So that'll be kind of fun. Schedule's a little crazy, unexpected, so my vote needs to be... Do not worry about that. Cam, I think what we're going to do is like, we're just going to go like season by season, you know, I mean, like season could be like a month or two, and we'll just figure out what schedule is working for everyone. I mean, you know, there's me, there's all of you. I want to see times that are like, you know, pretty good to stream on Twitch. I'm still pretty new to Twitch, so we're figuring all that out. But I did notice the other day that we got just enough sub points from some of those recent gift subs, and you know, Last Miles was generous, a bunch of you subscribed. That got us just enough to get another emote. So I think we're gonna have to get another emote commissioned. I have a whole list of emotes that I want to do, but I didn't realize that when you started off with Twitch, they give you so few emote slots. So I could give them a few bits from this Nintendo if they're really worried about it. Having a dedicated, yeah, I think that having a dedicated schedule is definitely. I mean, that's part of what I think works great with Tuesday nights. It's just being regular. And so even if I don't know exactly what we're streaming, I want to keep those time slots. And you know, I've got a whole pile of projects, so it's kind of like we can always figure that out then. But I want to stick to the schedule as much as I can. As long as real life doesn't get in the way, right? But anyway, thank you all. Thanks for following. Check out the Discord. Anybody who's not here, we already have dumpster fire. This code that I just wrote definitely qualifies for the dumpster fire emote. So I'll give myself the dumpster fire. Yeah, that one. I love the dumpster fire. That's fun. But yeah, so check out the Discord if you're not already there. I think pretty much all of you are there. I can't see who's here. It doesn't tell me. It's the viewer count that on like the creator dashboard just sort of jumps all over, so I have really no idea who's watching aside from when people talk. So anyway, thanks, have fun, stay safe, wash your hands, all that. You know, it's crazy times out there, so, and we're gonna keep on coding on this Nintendo and have some fun. So I will see you next time. Will be Saturday. So it's Thursday. Okay, cool. So yeah, Saturday. I'll see you Saturday. Take care, everybody.